Hello everybody, this is a video following in on the giant planets. In this video we'll be talking about clouds and storm systems on the giant planets. First we're going to start with Jupiter. Okay, so what kind of clouds, what kind of weather, what's going on in the atmosphere of Jupiter? In Jupiter, clouds are primarily made of ammonia. So we've seen ammonia, methane, hydrogen, and helium throughout the solar system. On Jupiter, we have ammonia clouds, but notice there's so many different colors. These colors are really just caused by chemical impurities. Different kinds of elements. It's not just pure ammonia. You get a little bit of this and a little bit of that, and you get a variety of colors. Different kind of chemistry going on there. The other really noticeable thing about Jupiter that you can even see through a small telescope are the light and dark bands or stripes. So there are strong dark and light bands or stripes. These are also known as belts or zones. The dark ones are belts, the light ones are zones, but for you, just think of them as bands. These strong dark and light bands are caused by winds, by alternating east and west winds. So alternating east-west winds, the winds blow some to the east and some to the west, and you get this striped pattern. So you can see where the wind changes direction on the planet. Pictures here, this one on the left is an infrared image. That's why it looks blue, but you can see the different stripes on Jupiter. And then on the right, a more traditional picture in visible light, where you can see the sort of colors that our eyes would see, the oranges and reds in those bands alternating across the planet. Well, the big feature on Jupiter that most people know about and easy to spot is called the Great Red Spot. It is great, it is red, and it is a spot on Jupiter. It is actually a long-lasting giant storm, right? Imagine hurricane, but this thing is a little bit crazier than any hurricane on Earth. Because for one, it is bigger than Earth. If we were to put, like my pen's not working here. Hold on, let's see if I can fix it. Be patient. Oh, it's my PowerPoint here. Come on, friend. I may have to pause this video, y'all. Sorry for that delay, y'all. I think my PowerPoint just locked up. But what I was saying is that the Great Red Spot is bigger than Earth. If we were to get Earth up there next to Jupiter, the Great Red Spot might be about twice as big. But there's some evidence lately that it could be shrinking. And this is sort of an interesting thing about this storm is that it has lasted a really long time, at least 300 years. So it's at least 300 years old. It was discovered shortly after telescopes were invented. Okay, so Galileo, looking at things, telescopes got a little better and people could see this storm. So it's lasted for a really long time, but it's not always exactly the same. So today it looks like it's shrinking. We've also seen that this storm varies not just in size, but it varies in size, shape, color, and motion. So the little squiggles and other sort of flows in the storm change over time. It gets darker, it gets lighter, it might get rounder or more oblong. So it's dynamic, but it's lasted for 300 years. The storm is opposite of what a hurricane is on Earth. The direction of rotation indicates that it has high pressure. That's opposite of a hurricane, right? Hurricanes are low pressure storms, right? The lower the pressure, the stronger the storm. This is high pressure. How do we know? It's because of the way it rotates. It rotates in the anticyclonic direction, but it's in the southern hemisphere of the planet. So that's opposite of what it would be on Earth, essentially. Cyclonic is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Maybe that's too much information, but this is counterclockwise in the southern hemisphere, so it's high pressure. So not the same as a hurricane. You can pause now and watch the video called New Science from Jupiter that talks a little bit about these storms. And there's some really cool looking storms at the poles of Jupiter as well. But we will move on to Saturn. So what do the clouds on Saturn look like? They are also ammonia clouds, but the color's a little bit different and the banding is different. So you have ammonia clouds and you do have a band structure like Jupiter, but it doesn't look the same as Jupiter, right? It has different sort of more subdued colors. And that says that there's a different chemistry. Remember, the colors come from impurities in the ammonia, different chemicals mixed in, and different colors indicate that there's different chemicals, different chemistries. Also, we can see one of the differences or one of the things that cause this difference is temperature. So Saturn, farther from the sun, a little bit smaller, conditions are different. You have a different temperature, different chemistry, you get different colors, and you get less banding. It's a weaker band structure, wider, less pronounced. So you can kind of see that in the picture as well. We do occasionally get individual clouds and storms on Saturn, but the individual clouds and storms come less often than on Jupiter. On Jupiter, we have the Great Red Spot, which has been around for a long time, but we often see these big storms. Saturn looks smoother most of the time, but occasionally you get some really awesome, amazing storms. You can get really violent storms that we know, we've studied, can actually make lightning, just like storms here on Earth. So there's no surface there's no surface on Saturn for the lightning to strike, but it's cloud to cloud lightning, and it's pretty cool. So there's also a video on the playlist that talks about these lightning storms on Saturn and how they were first discovered. So check that one out as well. So Saturn, weaker bands, subtler colors, fewer big storms than Jupiter. Now it's time for the last two, the ice giants. What do the clouds on Uranus and Neptune look like? So clouds on Uranus and Neptune. They have bands as well, but you can't even really see them very well. They are weaker even than Saturn, so the bands are weak. Bands are weaker. You can kind of see them on the right in this infrared image of Uranus. That infrared helps us to see the bands a little bit better. What we also see on these blue planets are small, bright clouds or dark clouds. And they're often isolated. So you have small, isolated, bright clouds or dark clouds. So the bright clouds look white, much like on Earth, but then you have darker, like deeper blue colors as well. Most of the clouds are not ammonia, like Jupiter and Saturn, but mostly made of methane. So you have methane clouds, small, isolated, bright clouds or dark clouds, mostly made of methane on these planets. We do, again, see storms, but they tend to come and go. They are temporary. None of these 300-year storms like we see on Jupiter. You have temporary large storms. They might stick around a little more than on Saturn. But for example, there is this famous one, which you can see in the left-hand picture. It is called the Great Dark Spot, sort of like the Great Red Spot, because when it was first discovered, we thought, hey, that looks just like the storm on Jupiter, but dark. We found this one on Neptune, so the Great Dark Spot was on Neptune, but then it disappeared. So the Great Dark Spot on Neptune disappeared after about 5 years. So we finally got the technology, the telescopes where we could see the surface of Neptune, but then we were able to see a change with time. It's not a 300-year storm. So the Great Dark Spot is gone. There's been another one that's come since then. So these things come and go here. Here is a poll just for a little bit of your reference here. What causes the bands? Right? Think about this for a minute. Pause it. Think about what's the right answer. The bands are caused by winds. Remember we said that winds, east, west winds. Some winds go this way, some go that way. So you get the bands. If you do not have bands or you have weaker bands, then that means your winds are different. Okay, so that's the best answer there. That is the end of this video. I'll have another one on the interiors of the planets, so catch that one next.